Hi everyone, welcome to Economic Odyssey. This is the second microeconomics chapter that I'll be explaining. These are two of the books that I recommend for this course. And these are all the sections that I'll be covering in this lecture. Okay, let me start this lesson with the question, is going to university worth it? I encourage you all to pause the video here and think about this question. Okay then, well in the UK it costs us £9,250 each year and around £18,000 for international students. But do we have an alternative option to go into its university? Is there another choice? Is there another route that we can maybe take? Well, yes, in the UK we have a program called the apprenticeship where students can start earning as soon as they leave college and have an opportunity to earn a university equivalent degree as well. But how do we make such important decisions? Well, we need to take certain factors into account when making these decisions. We would need to consider factors like return on investment, i.e., which option is more rewarding at the end, growth opportunities. Does going to uni increase your chances to start at the managerial level in comparison to the apprenticeships? Cost effectiveness. Which option is likely to be a feasible choice for yourself and your current situation? And reviewing the pros and cons of your choices. Well, there are numerous other questions that arise when picking between taking up a job or going to university. And this type of analysis is something that we will be looking at in this lesson. Okay, so one way to determine which option to pick is by using the scientific method. Last lecture, we looked at empiricism, where economists use logical reasoning to support their hypotheses. The scientific method is the name for an ongoing process which is used to create, develop models, and test those models with data. As the world mechanisms are largely complex, economists do not expect the created model to be a true reflection of the real world. Models which have a higher number of inconsistencies are replaced or changed altogether. All the models created begin with an assumption, and these assumptions are referred to as hypotheses. So we know that all economic models begin with assumptions. Let's look at an exam style question about using the scientific method. Well, consider the following about the returns to education. Investing in an extra year of education increases your future wage by 10%. Let's put this assumption to work, generate a model that shows links between a person's level of education to their wages. Your first step would be to put wages, which equal to W. The W here represents the wages. Then we need to find the 10% of our wages, which would be W times 10%, or it can also be written as W times 10 over 100. To find the total wages, which would be in the future, you would need to do W and 1 plus 0.10, which would increase our percentage by 10%, which would give us W in brackets or W times 1.10. Moving on, now let's assume that we have £15 per hour as our wages. We know how to use the formula now, so we can directly skip those steps and plug in our value with the W times 1.110. So here the W is £15, so it will be 15 times 1.10, which would give us £16.50 for every extra year that we are in education. So the formula for 1 year is W times 1.10. And the formula for any number of years, let's say if you want to find out for year 2s, year 3s, year 4s about the number of wages that you've earned, you would need to use this formula. W times 1.10 to the power of n, where W is for wages and n is for number of years. So two important features of this model are that they are not exact, meaning not everyone will see their wages increase by 10% with every additional year of education. And They generate predictions that can be tested with data. Again, this is something that we looked at in our previous slides, that seeing that this is an assumption, this will not be a true reflection of the current world. And it can show a prediction to a certain extent, but is not 100% reliable. Okay, so let's look at another exam style question. How much more do workers with a college degree earn? Well, we have Exhibit 2.3, which looks at average annual earnings of 30-year-old Americans by their education level. Okay, so we know that college graduates earn $51,215 in comparison to high school graduates, which earn $32,912. To find the percentage difference, we would need to divide $51,215 by $32,912, which would give us 1.556, which then would equal to 1.56 to 2 decimal places. Hence, people with college degree earn 56% higher than high school graduates. Now, here's a question for you. If a college graduate earns on average $51,215 per year, does that mean that all college grads earn a similar wage? Okay, moving on to understanding causation and correlation. Let's look at this with a case study. You're at Walmart and Walmart has hired you as a consultant. You have developed a hypothesis about its ad campaign and found out the use in the red color is good at catching customers' attention. You put your hypothesis to test by assembling empirical data from historical ad campaigns, which looked at the connection between color and revenue at Walmart. Your data confirms your hypothesis, and sales go up by 25% when the color red is used in comparison to 5% when the color blue is used. You take your hypotheses and results to the CEO. However, the CEO fires you on the spot. Now, what did the CEO notice that you missed? Pause the video here, think about the case study, and write down your answers. Okie dokie. So the CEO noticed that the red theme was used during Christmas, and it was the season of Christmas. It was the festival of Christmas that increased Walmart's revenue and not the color. The revenue would still increase by 25% regardless of the campaign colors. Giving an incorrect hypothesis to the CEO costed you your job. Now, this is where we look at understanding the causation and the correlation between two scenarios that seem linked together but are not. Okay, let's start with looking at causation. People often mistake causation with correlation. Causation occurs when one thing directly affects the another. You can think of it as the path from cause to effect. An example of this can be putting a snowball in a hot oven causes it to melt. On the other hand, correlation is where there is a mutual relationship between the two things. Where one thing changes, the other thing changes as well. Correlation can also arise when causation is not present. An example of this can be the students who have taken music lessons tend to score higher in their GCSEs. GCSE scores and music lessons are only correlated with each other, and the causation here is not present. Correlation is divided into three categories. The first one is positive correlation, where two variables move in the same direction. Example, an increase in ice cream sales during hot weather is quite prominent and would be an example of positive correlation. Second category is negative correlation, where two variables move in the opposite direction. And an example of this can be people with higher level of education are less likely to be unemployed. And the third category is zero correlation, where two variables are not related with each other whatsoever. And an example of this can be the number of friends you have has no relation to your house number being odd or even. This diagram clearly shows how causation and correlation are interlinked and are not interlinked at the same time. If your battery runs out, your phone is going to shut, and that is a cause of your battery being run out. If your battery runs out, your camera won't work, and that's also another cause. Whereas if your phone shuts, your camera won't work. And that means if one thing changes, i.e. your phone shuts, the other thing changes. That is, your camera won't be working. And this is how causation and correlation is interlinked with the world economics. Yes, but how do we know when causation does not imply correlation? There are two reasons which show that correlation between two variables implies a particular causal relationship. The first one is omitted variables, and the second one is reverse causality. Omitted variables is something that has been left out of the study. If included, would explain why the two variables are correlated. And reverse causality is the situation when we mix up the direction of the cause and the effect. And an example of this can be relatively wealthy people tend to be relatively healthy too. We can also put this sentence as better health may cause greater wealth. And this is when the statement can be reversed twice to give the same cause and the same effect. But how do we tell the difference between causality and correlation? We use something called the experimental economics. Controlled method is one of the following methods used by economists when carrying out experiments. This is when subjects are randomly put into treatment, i.e. when something happens, and the control, when nothing happens, groups by the researcher. The problem with this method is that it is difficult to do with economical studies. It is more medicinal or medicine-based. Natural method is when subjects end up in a treatment or control groups due to something that is not purposefully determined by the researcher. A con of this method can be it's time consuming and it can turn out to be quite. Okay, so when conducting research, economists needs to ask questions, and these questions need to have answers. So what are good questions that economists may ask? Well, good questions come in many forms, and the two properties of a good economic questions are it should be relevant and important. Economic research contributes to social welfare, thus it is important that for it to be for the current world and not related to the past. It can be answered empirically, i.e., the economic research that has been carried out can be proven with data analysis and with good reasoning and hypothesis, which can be stated clearly in your research. Okay, so we have come to the end of our lesson. Here are some exam style questions for you to answer. Please let me know if you guys have any questions about this lecture or any suggestions in the comments down below. I hope to see you all next time. Bye for now.